Hey everyone, hope you're doing well. We're going to be looking at quadratic visual patterns again. So we've looked at visual patterns before that were linear, but now we're going to look at patterns that are quadratic. And the point of this video is going to be to show you some examples of different visual patterns and then how you can actually create an equation that gives you the pattern rule. And then later on you're going to be applying that to a graphing task. So this is our first pattern. We have figure 1, figure 2, and figure 3. So this figure has 4 squares, this figure has 9, and this one has 16. So just based on that, you probably can already get an idea of how many blocks will be in figure 4. If you said, oh, I bet there's 25, then you were right. So what we're going to do with this is just try and create an equation that actually represents this pattern rule for no matter what the figure number is. So just like we did with the word problems, we're going to define some variables. So we will let x be the figure or pattern number. I just said that because in some of these examples, they actually they'll say like pattern instead of figure. So x is going to be the pattern number or the figure number, and then y is going to be the number of blocks. In the figure. So we are trying to create an equation that will actually relate the figure number or the pattern number to the number of blocks. So just so that you can kind of see what we're starting off with, we'll do like an x and y table. So we have figure 1, we have figure 2, and we have figure 3. And then if y is the number of blocks, in the first one we had 4 blocks. The second figure we had 9 blocks, and then the third figure we had 16 blocks. So you could figure out the pattern without having an equation probably and continue to go forward up until a bunch of different steps. But I'm going to show you how you can actually look at these particular blocks to think about an equation that you would make. So you probably remember that we've done a lot of work with like area models and representing binomials as like the sum of an area of a rectangle, and it's the same kind of line of thinking here. So these are all squares, right? You can see that they're squares, and then the number of blocks could be represented almost as an area. So here, this is 2 blocks by 2 blocks because that gives you the area of 4. And then we would have to ask ourselves, all right, well, we want an equation that relates the figure number to the number of blocks, or that relates x to y. So in this case, x equals 1, and there x equals 2, and x equals 3. So what would be something that we could do that would relate the number 1 to the number 2? And in this case, I would think, oh, okay, well, 2 is 1 more than 1. So if x is 1, like 1 plus 1 is 2, so x plus 1. And then, the same thing would apply there. X plus 1. So let's see if that applies to the other. This is just my first thought. So now I would look at the other blocks and I would ask myself, I wonder if this applies to the other patterns as well, the other figures. So here, when x is 2, let's just see x plus 1, 2 plus 1 equals 3, and are there 3 blocks? Yes, there are. Nice. And then let's look at this same here, because it's a square. So x plus 1, we've already proven that it will work. And then here, if x is 3, let's check this one. So check if x plus 1 will work. When x is 3, that would be 3 plus 1 equals 4, and there are 4. So good. It looks like we found an expression that can represent the length and the width of these squares. And then to figure out the actual number of blocks in the figure this is like the area of the figure. So we have, in this case, we want to create an expression that's like the area. And we've done this before with factoring and expanding. So the area, in this case, the area here is x plus 1 times x plus 1, which is going to be x plus 1 squared. So therefore, y, or the number of blocks in the figure, for any pattern or figure number is going to be equal to x plus 1 squared. And then that would be the final answer there. All right, let's try another one that's very similar with just one additional step. So you've probably actually noticed fairly quickly, right from just looking at these pictures, that the purple components of the figure are actually the exact same as the previous example. And you would be right. So we still want to make an equation of this. So we're going to say let x be the pattern number, and let y be the number of blocks in the pattern. So again, the same idea here is that we're just trying to train our brains to think in terms of the areas of a shape. And then this one is nice because it gives you a couple of different colors to help you tell them apart. So in pattern 1, x will be 1, and here x will be 2, and then here x will be 3. So just like with the last example, we've already seen that the side length in every pattern is x plus 1. But then in each case, notice how only the purples are changing, and then an orange block gets added to the top of them. So if we want an equation that actually says how many blocks are there in the pattern, we know that we're going to start off with the y, so this is the number of blocks, x plus 1 squared, because the area of this would be x plus 1 times x plus 1, and then one additional block is being added on each time. So the equation is just going to be y equals x plus 1 squared plus 1. And then if you were ever interested in trying to expand this, so we're not going to do it for the sake of this video, but you could have a question where the equation, you may be asked to expand and simplify the equation. So keep that in mind. I'm not going to show that in this video because that would be previous lessons. So now we're going to look at another example. We're going to make an equation that represents the number of blocks in this pattern. So we'll say let x be the pattern number, and then let y be the number of blocks in the pattern. So if we have pattern 1, that means the x value will be 1, and here x will be 2, and then here x will be 3. So we want to figure out what is some kind of an equation that can relate this number to the number of blocks in the pattern. So I'm just going to make a table of values to start off with, give us some information there. So we have 5 blocks at the start, and then we have, how many here? There's 8 after that, and then we have 9, and then we have 13. Alright, so another thing about the visual patterns is that you kind of have to look at them in parts. This is where the colors are really helpful. So you probably have also noticed right away that no matter which pattern you're looking at, there's always 4 pink blocks. So that's going to be very similar to this part from the last example, where we're adding 1, only now it's just we're adding 4 pink blocks no matter what. And then here, let's look at the area that you could represent the blue blocks with. So we have, this is just 1, so that would be equal to x, because there's just 1 here. And then here, we have 2 blocks there, which at the same time, that's just x, right, because it's 2. And then one of the side length here for this square would be 3, but as we know for the blue, that's just x. So if we want to find the area, of the blue blocks, that's just going to be x times x, because it's a square, which means all the side lengths are the same, and they're equal to x. So if x was 3, that means the length of one side of the square was 3. When x was 2, the length of one side of the square was 2. So that means we're going to get x squared for part of our equation. So the blue part is going to be the x squared there. And then no matter what pattern we're in, we're always adding 4 pink blocks. So that's going to be plus 4. So we could test that. So let's say when x is 1, we would have 1 squared plus 4. Would we have 5? Yes, we would. And then if x was 2, that would be 4 plus 4. Do we have 8 blocks? Yes, we do. And then in pattern 3, if x was 3, it would be 3 squared plus, which is 9, plus 4. Yep, so that one is also right. So then this would be our equation. And then since there's no brackets to expand, that would be the fully expanded and fully simplified version. So those were just a couple of examples of visual patterns and some of the things that you should look at when you're actually trying to come up with an equation. When you're graphing these yourself, you're going to have a couple different options to pick from. And then the one that you choose will kind of show like how much are you really able to pull out an equation from these diagrams.